Let's go over our review. Number one is asking you to find the slope. What does the slope of the, that should say table, represent? And it represents, the slope will represent y per x. So y says file size, x says the time in minutes, so that it's going to be the file size per minute. Just that simple. Number two, a painter charges $25 per hour for labor plus $30 for a ladder rental when he paints a house. Guys, I'm hoarse, so I'm sorry. I'm doing the best I can. Write the equation that describes the function of labor hours. Remember, when you see those words, that is f of x. So the independent variable would be labor hours. I'm just throwing that out there because I know it's going to ask us that later. But anyway, it wants us to write the equation that describes the function of labor hours. So up here when I have slope, I'm looking for y per x. But down here when I'm writing the equation, I'm looking for those words that mean each, every, a, per. And wherever that word is, it's going to hopefully be next to a number or in the same sentence as a number. It's going to be applied to one of the two numbers in the problem. 25 and per, they go together. They're partners. The per is applied to the 25, not the 30. That means the letter will go next to 25, not the 30. So the answer has to be A. It cannot be D. You don't add them together. It cannot be C. The per did not apply to 30. Number three, it says the same painter is going to increase what he charges to $55 every hour. And the every is applying to 55, so I know 55 is going to get the letter. And then the rental fee, that's in addition, every does not apply to the 30, so I can just add it on. It wants to know what's the rate of change. Well, remember, the rate of change is the number next to the letter. This is the pattern. That's the slope. 55 is your rate of change. Rate of change, M, that's the same thing as slope. Number four, which below describes the slope? It's going to be y per x. And what is that going to be? The amount charged per hour. The amount charged per hour. Okay, moving on. Number five, the function of labor hours that will be used to paint ladders is represented by this here. F of x equals 40 plus 55. X. What is the independent variable? Well, remember earlier I told you F of x. X is going to be the number of labor hours. Do you see an answer choice that talks about the labor hours? Well, this says amount charged. That's 55. That's the slope. How do I know? Because it says each. And I know whatever is by each, that's going to be my slope. So no, I'm not asking for the slope. Slope is not independent. The letter next to slope, x, is independent. The total amount charged, that's the final result. That's the dependent variable. Remember, on the x-axis hangs the I, so x is always independent. And on the y-axis sits the D, so D is always dependent. Y is always dependent. Now, the labor rental fee is going to be the 40, and that's the y-intercept. And this asks for the independent variable, so the answer is B. Number six, an architect is designing an office building with end floors that will have an FM radio antenna of 1385 meters tall on its roof. Each floor of the building will be 3.7 meters high. What is the change in y over the change in x? So I'm asking you, what is the slope? Okay, each floor of the building will be 3.7 meters high. 3.7 each is being applied to 3.7. So 3.7x plus the additional height of the antenna. I want to know the slope. Which one is the slope? The slope is next to the letter. So the slope is 3.7. How do I know that? It's going to be the height per floor. All right. Number 7. Now, I already know because you see a table, you guys are going to start doing this. But when you start doing that, I want you to notice, look how you're getting all this different stuff. Are you going to be able to find an accurate slope with all of these different things going on? When we didn't do that, did we? No, we didn't. And even on this side, it's going to go up 4, and then from -2, it's going to be -1, and then 0 is going to go up 2, and then go up 4, and then go up 6. I mean, seriously? Okay, that's going to happen on all of them. I did that on purpose because I didn't want you to find the slope that easy. Number 7 says, which table below has the same rate of change of y with respect to x? And this is the equation I wanted you to figure out as a slope of 1/2. This has a slope of 1/2. There's a slope. Which table has a slope of 1/2? I know you like, I'm confused, miss. I don't know. If I can't do this, how am I going to figure out which one has a slope of 1/2? Okay, well, 2 divided by 4 gives me 1/2. 1 divided by 2 gives me 1/2. 2 divided by 4 gives me 1/2. 3 divided by 6 gives me 1/2. Ah. Looks like the answer is C. Can I check it using the calculator? Let's see. Let me go home and do new document because I don't want to see what everybody else had. 10 plus control divide 1 divided by 2x. What did I do wrong? Oh man, I used control divide, so I can't use the division. I have to do control divide, put the 1 at the top, put the 2 at the bottom. What did I do wrong there? I put the x at the bottom. How do you get the x off the bottom? Oh, press over, that's right. And there it is. Press enter. I have my line. Press control T. I now have the table, and you can check it. 0, 10, 4, 12, 10, 15, go down to -2, 9, and go up to 10. Oh, that says positive 10, so let's go down to 10, positive 10, and it says 15, so we're good. If you want to check -6, 7, you can. You have to go all the way up to the negatives. There it is. -2, 9. There it is. So this is truly the answer. So I know you're like, Miss, but we didn't do many of those. You're right, we didn't. So you've seen it on your review. We have our review day in class. We'll make sure we practice and cover that. Number 8, which table below is going to show a rate of change of -5/8? Now this is the second time I've seen this, and I know you're probably tripping. Miss, what is y with respect to x? Let me help you out. All it means, give me an equation that says y equals and put x on the other side. That's all you have to do. It's just that simple. So, when you see y with respect to x, know that it means y equals and have an x on the other side. We want 5/8, so we can do the change here. And you can count up. So -11, -10, 9, 8, 7, 6, 5, 4. So that's going to be 8, right? So going up 8. And then from -4, you're going to start at -3 and count. -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Going up 12. And then this one is going up 12. Okay? And then on this side, we're going to go from -2 to -1, so that's +2. -1 to 2 is going to be 0, 1, 2, so up 3. And then go up 3. Okay? Now, from there, what do we do? Change in y over the change in x. So 8 over 2 is going to reduce to 4. 12 over 3 is going to reduce to 4. 12 over 3 is going to reduce to 4. But I want slope of negative 5/8. So A is not the answer. So you can keep doing that for each one. Now, is that going to be fun for this one right here? Nope, because look what you got to do. And I know you're going to hate that. So what can we do? We can use the calculator. And let's press enter. No, I do not want to save it. I need a graph, and I want to type in the equation 4 minus control divide 5 over 8. And I need an x. What do I do to get the x? Press over first. Press my x. Press enter. Press control T. And there it is. For negative 4, 6.5. For positive 2, 2.75. For 4, 1.5. And for 8, negative 1. So there it is. That's my answer, and we're good to go. Number 9 wants to know which one is the less steep. We've talked about the steeper line, but we haven't really talk a lot about the less steep line. Well, it's just going to be the opposite of what you've been doing. So if I extend this line here and then extend this line, I can see that this line doesn't look like a scary ride compared to this line. So since this is less scary, this is less steep. And remember, when I say less scary, I'm talking about a roller coaster. So if I'm riding on this roller coaster, I'm going up here, or going up a hill, this looks a little scarier, or a lot scarier than that. So this is less scary, less steep. And number 10 wants us to find a situation that interprets the graph on number 9. Real quick, let me go back real quick. I know you're saying, why didn't you do anything about number 2? Because remember, number 2 has a slope of 0. So I can only look at number 1 and number 3. So that's why I didn't. Number 2 is not even an option. Number 2 is not an option. Okay, back to number 10. Which situation could be used to interpret the distance versus time graph on number 9? So the person is going up, they're standing still, and they're going up more. Since this is steeper, they're probably going faster at the end. So does Tim walk fast to the store at a constant rate? After walking for 5 minutes, he went back home? Well, home is here at 0. So I'm at home, I'm walking, I stop. Do I go home? No, they keep going. Home would mean to come down. So it's not A. Tim walked at a constant rate from home. Hold on, guys, the lights just got turned off. Mr. Marcus, I'm in the middle of a video on YouTube. You gonna be publicized. That's all right. I sure did say it. See you later. All right. So letter B. Tim walked at a constant rate from home, stopped to tie his shoe, then walked slower than before to the store. So Tim walked at a constant rate from home, stopped to tie his shoe, and then walked slower. Ooh, did he walk slower than before? If this line is steeper, then that means he walked faster. Okay? So that's not right. Letter C. Tim walked slowly for 5 minutes to the store at a constant rate. He stopped for ice cream and then walked slowly to his destination. No, he didn't walk slowly. Tim decided to walk to the mall from home, stopped to look at the stars, and then ran the rest of the way. That would be the answer. Because this line is steeper, he's going to go faster. Number 11. A line contains the point negative 1, 2. So negative 1 go up to 2. And it has a slope of 1/2. So this line has a slope of 1/2. So 1 over 2 means to rise and to run. I'm going to go up and then go right. So I want to know what happens when I do that. So let's do it. Go up 1 and to the right 2. Up 1 to the right 2. Up 1 to the right 2. Up 1 to the right 2. And then we can go the other way. Down 1 to the left 2. Down 1 to the left 2. Down 1 to the left 2. because going up and right is the same thing as going down and left, because a negative divided by a negative is a positive. How do I know? If you use this triangle, a negative divided by a negative is a positive. So, which of these points is an answer choice? Is 1, 2 another point on the line? No. It's the point I started with. Well, actually, it's negative 1, 2. I'm sorry. So let's look. Is 1, 2 on here? Oh, no, that's 1, 3. So it's still wrong. Okay, and I'm looking at the answer choices. So 3, 4 is not 3, 3. So that's not it. 3, 4, there it is. There it is. I found it. And this is 6. Well, the answer's not 6, 3 because 6, 3 is right here. So I know D's not it. So I know I got it right. Okay, let's do number 12. Given 2 points, x, 2 and 5, 8. If m equals negative 1, what should x be? So we're going to do x1, y1, and then x2, y2. So I need to do 8 minus 2 over 5 minus x equals negative 1 over 1. Now, if you learned how to do this the long way, you knew that there was a fraction missing right in here. And you knew that 8 minus 2 would be 6. So 6 over what would have been this 1. And hopefully he said negative 6. Hopefully. Hopefully. Now, if this doesn't make sense to you, just hold on. Let me finish this explanation and I'll show you the shortcut. So now that we know that 6 over negative 6 is the same thing as a negative 1, 5 minus what number is going to be negative 6? Well, 5 minus 1 is 4, so I know it's not that. 5 minus 4 is 1, but it's not negative 6, so it can't be C. 5 minus 11. 5 minus 11. What is that? Well, that's 5 plus a negative 11. So 5, write 5 plus signs. 1, 2, 3, 4, 5. Write 11 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Cancel, 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 cancel. How many negatives is that? 1, 2, 3, 4, 5, 6. Because remember, I canceled that one out right there. 1, 2, 3, 4, 5, 6. That's negative 6. That's what I have. That's my answer. Now, for those that freak out, when you get here and you write this and you say, Miss, I didn't get that. I can't do that. I don't understand that. Okay. Well, we know this is supposed to equal negative 1, right? Just plug in your answer choices. And I'm going to hit home. I think I hit control home and turned it off. So now you know how to turn your calculator off if you didn't know. So I'm going to hit on, and then escape. New document. No. And we're going to do calculator. I'm going to do control divide. And I'm going to do 8 minus 2 over 5 minus. Plug in A, B, or C. So if I plug in the 1, which was B, it will not give me a negative 1. So that's not my answer. But I can press the up arrow, press enter, pull that down. And instead of 1, I can do 4. So put in 4, press enter. What do I have? 6. I want negative 1. That's not it either. So I'm going to go up, press enter. Do delete and put 11. If it gives me negative 1, I know I did it right. And it did. So the answer was 11. Number 13. Which line below has a slope of 0? Well, hopefully you remember him. Negative, positive, nose, undefined for vertical lines. The mouth, horizontal lines have a slope of 0. Slope 0 is B. That's what the mouth means. Horizontal line, slope 0. Vertical lines have a slope of undefined. Which table below is linear? Okay, so now I think we'll be able to do our more practice on finding what's going on here. So 2 to 1 is going to be, I put plus 1, but that's going down 1. This one is going up 1. This one is going, let's make sure I did that right because I am Russian, sorry. Down 1, plus 1, plus 1. I did something wrong. Down 1, 1 to 0, going down 1. Sorry, that should be down, so that should be negative. Slow down, Ms. Pearce. 0 to 1 plus 1, 1 to 2 plus 1. Let's come over here and do this one. Do I need to do this side knowing that these don't match? No, I'm good. Because they have to match before it's going to be linear. Okay, so from 12 to 6, down 6, down 2, down 1, down 1, up 1, up 1, up 1, up 2. Okay, so is this going to be linear? No. And then what about this one? Up 2, up 4. And what about this one? This one's going up 8. This is not linear, is it? And then this one here is plus 3, plus 3, plus 3, plus 3, plus 1, plus 1, plus 1, plus 1. So is this one linear? Yeah, we found it. We found it. Number 15, which equation below is not linear? Well, I have a y and an x, and the highest exponent on the x is a 1. And how do I know that? When you don't see an exponent, it is 1. So that is linear. That has a 2 on it. That's higher than 1, so that's not linear. And this is not linear because the x is at the bottom. Y and an x, it doesn't have an exponent, so I put a 1, so it is linear. Y and x, and I don't have an exponent, so I know it's 1. That is linear. So this question says which one is not linear. So it would be 2 and 3, which is A. Okay, so let me bring that down just in case you couldn't see that. And I'm showing you that which equation below is not linear, so it's not 1. Number 1 is linear, number 2 is not, number 3 is not, number 4 is, and number 5 is. But the question is saying which one is not linear. I'm going to do number 16, and my lovely friend just walked in, so I'm going to let her do 17 and 18, talking about simplifying expressions. And let's do number 16. Which equation describes the graph below? So I see that it goes through the origin, but I cannot assume that this is the linear parent function yet. I cannot assume that it's the linear parent function, because in order for it to be the linear parent function, it has to be y equals x. And so when I have an x value, is it the same as the y value? So my x value says 1, and my y value says 1, so I'm good. Now let me check a few other ones just to make sure. My x value is 3, my y value is 3, I'm good. My x value is 6, my y value is 6, I'm good. The x value is 9, my y value is 9. Let me check the negatives. X is negative 3, y is negative 3. I know this is the parent function, and it is the linear parent function. So, since my y equals x, there it is, answer choice C. Alright, Miss Nguyen is going to come and do number 17 and 18. Give her your attention, please.
Ooh. I don't know if I can keep up with her. Let's see. Looking at number 17, I like color, so let's do this. So when we simplify expressions, and I realize that's new. Did I move up? There you go. Simplify expressions. We should try to do, I don't know if you know this yet, but PEMDAS. So let's try PEMDAS. And if you may or may not know this, we'll go through it anyways. This P stands for parentheses. This E stands for exponents. Okay, I'm going to write the word exponents. And most of y'all know it as like a number 2 at the very top. It's that tiny number at the top. It's called an exponent. M stands for multiply. D stands for divide. A stands for addition, and S stands for subtraction. And so this is my order that I'm going to go. Okay? So let's look at the parentheses. I always do parentheses first. Can I subtract x minus 3? I can't, just because this x is a variable and this is a number. So I can't do anything with my parentheses. Do I have any, well, let me fetch that out. So I can't do parentheses. Okay. Do I have any exponents? Let's look around. Do I have any exponents? No, I don't. So I can't do anything with exponents. Okay? And then there's multiplication. When you've watched the algebraic expression, this multiplication, this distributive property is also called multiplication. It's also considered multiplication. So we're going to distribute, so I'm going to write the word distribute, and so that means we're going to give this negative 3 to each number here, or each letter and each number inside that parentheses. So negative 3 times x gives me negative 3x. Negative 3 times negative 3 gives me positive 9. And then I'm just going to rewrite what's left. Plus 2x. Sorry, it's all over the place. Okay, so I'm done with multiplication. Do I have any division? Looks like I don't. Let's add. I have a bunch of additions. What can I add? Should I add 3x, negative 3x and 9? I probably shouldn't because this one has an x and this one does not. But this one has an x, so why not add those two? What's negative 3x plus 2x? That would be negative 1x, or in other cases you could say negative 1 or negative x plus 9. Okay, you can have negative 1 there, or it's also written as negative x plus 9. Those are the same thing. It's understood that there is a 1 there. So which answer choice goes with that one? B. Yay. I know that was a bit complicated. It's kind of new. So we're going to practice another one. Okay? Same thing with PEMDAS. I'm going to use the same thing. I'm going to rewrite it here for you. PEMDAS. I don't know. I learned it as please excuse my dear Aunt Sally. Whichever helps you, it doesn't matter. So, parentheses. Can I add y and 4? No, because this one has no variable. So I can't do parentheses. There's no exponents anywhere. There's no tiny numbers like that anywhere. So the next thing to do is to multiply. So let's multiply. 2 times y and 2 times 4. Negative 2 times y. Don't forget it's negative 2. That negative sign goes with the 2. Okay? So we're going to go, what's negative 2 times y? Negative 2y. Negative 2 times a positive 4 gives me a negative 8. Okay, don't forget that 11, I'm just going to drop it down here. So that's what I have so far. Okay, so let's simplify it. I'm done with my multiplication. Let's do division. There's no division, so I'm going to keep going. Let's add. Do I have any addition? Nope. Let's do subtraction. I want to subtract the ones that either has the variable or without the variable. So this y is by itself. I can't really do anything with this negative 2y. So let's subtract 11 minus 8. What's 11 minus 8? 3. So it's going to be negative 2y plus 3. It's a positive 3. So which answer gives me that? That's kind of tricky. There's like 2 y's and 3's, right? So this is negative 2y minus 3. So that's wrong. There's a negative 2y, so there's no negative there. Negative 2y plus 3. Yay. And we got how many more? 3 more. No, 4 more.
Okay.
All 4?
All 4.
Okay. We'll do all 4. Not much. I know it feels like it's a lot, but don't worry. Okay, so we're going to fill in the blank. Steeper. Okay? I don't remember if you remember this in class, but steeper, when I find a slope, we're talking about slope, okay? So make sure you know that's what we're talking about, slope. So when you look at a graph, there's this line, or this graph.
Bring it down some.
Oh, sorry, I'm so sorry. I didn't realize, I'm not used to this. That's okay. And what's the difference between this graph and this graph? I should have done that in color. Okay? You'll notice that this is closer to a vertical line. Okay, or when you want to think of a hill that's more steep, you think of it as something that's closer to a vertical line, right? And so when you think of something that's steeper, would okay, so steeper slope, we're talking about my M, okay? My M is my slope. I feel like I'm all over the place.
No, you're good.
Okay, so with my M, let's think about that. So y equals, let's try a 2x, and let's try a y equals 1/2 x. So you can see the difference. This is, my big slope is 2, and then the slope is smaller here as 1/2. Okay? Should I try to do it in the character? Okay, so if I do 2x, y is 2x. That means this is my y equals 2x. Let's start at 0 just for now. My slope here is 2 over 1. So we're going to rise 2, 1, 2, and go over 1. Let's do that one more time so we can see that. Rise 2 and go over 1. Okay. So here is my line.
Nice.
Y equals 2x. Okay, so let's try this 1/2. I'll move it up a little bit so you can see it. Okay, this is my 1/2. That means my slope here is 1/2. That's where this is coming from, okay? So let's start 0 just for the heck of it because, I don't have any points to start with. Okay, so that means I have to rise 1 and go right 2. 1, 2. Rise 1 and go right 1, 2. Okay, as long as I have 3 points, I think I'm okay. And let's draw this graph. Which one is more steep? The one with the bigger number? I'm sorry, let me write this. Y equals 1/2 x. Or the one with the smaller slope? And it kind of looks like the one with the bigger slope makes a steeper graph. So, when you look at the answer choices, is it A, the smaller the slope becomes, the steeper the line? So the steeper the line, the less the slope changes? The steeper the line, the more negative the slope becomes? We didn't really say anything about positive or negative. So the steeper the line, the larger the slope becomes. Which one do you think make more sense? And I think that one, we concurred, that 2 makes a steeper slope than 1/2.
Wow. So the bigger the slope, the bigger the line, or the steeper the line?
Yeah,
That's pretty cool.
I didn't realize that either. So, we all walked through this. Okay? Domain and range. Let's go back to that. Okay? I don't know. I kind of like to think of this as a snake, and I really hate snakes. And so this line right here is a snake. Okay? And we're going to box this snake. Snake. Haha, sorry. So, when I do domain, it's my doors. It's my left and right doors, and we're looking at left and right. My left door, and so we're going to close it in a box, and that's what I'm trying to do, and my right door. So my domains go from left to right. So let's keep that in mind. So my farthest left that I could possibly go, it looks like it stops at -4, but when you notice that there's an arrow, that means this snake doesn't stop, it continues, right? This arrow tells me it continues to -infinity. Okay? And so, well, at least this is what I taught my class. I'm sorry if I'm confusing you, but we'll go back to it. So it goes from -infinity, and where does it stop on the right side? What is the farthest right I can possibly go? That looks like it crosses through the x equals 3 line. Okay? And since my domain, we learned, is x. So that means this graph goes from -infinity to 3. It's not greater than 3. So if I ignored this negative sign here, it shows me that x is less than 3. That means it cannot go past this 3. Okay, so for sure, which one can I eliminate? It looks like I can eliminate this one and this one, C and D. And so let's do range. Okay, with my range, I like to think of it as my roof and my floor. Okay, so my roof, the highest possible of my graph, and the lowest possible of my graph. Okay, and obviously when you think of roof and floor, the floor is the lowest, right? So let's go with the lowest. What is the lowest possible that my graph can touch? and it looks like it's -2. Oh, I made a mistake too, and I'll come back to that. Okay, so, I mean not -2, it's 2. So 2 is my floor, and I'll keep this inequalities, and we know that range is y. Okay, so what is my highest possible? What is my roof? When you look up here, it looks like it goes to 7, even though that's not there. And you look over to my graph, it's an arrow. So it doesn't mean I stop at 7, it means I keep going to infinity. Okay? So, when I ignore this infinity sign, just for now, ignore it. It means it says that 2 is less than y, which can also be rewritten as y is greater than 2, right? So the one mistake that I totally forgot to mention was that this is a closed dot, okay? And when there's a closed dot, you must include these numbers, okay? You must include them. So if I have this line underneath it, which option is my best option here? And it looks like it's B. Okay, I'm sorry I didn't mention that earlier, but that's what you should focus on. Focus on the graphs, and so this is a closed dot. I need a line, and if there's an arrow, it goes to infinity.
Nice.
Yeah. So, let's look at this last one. No, sorry, 21 and 22. When we are trying to do characteristics or find characteristics of a slope, which one is undefined? I don't know, I kind of like to look at my slope man. Okay, so, I mean, I'm going to redraw this slope man, and I'm pretty sure you've seen it. That right there is a negative slope. That right there is a positive slope. Oops. A vertical line is undefined, and a horizontal line is 0. If I want undefined, which is his nose here, what kind of line was that? I'm pretty sure that's a vertical line, right? Vertical line. Other things that you may see for it to be undefined, and you could probably try this in your calculator. If you put, let's say for instance, 3 over 0, can I divide 3 divided by 0? Like, if you tried it in your calculator, or even did this, 0 divided by 3. How many times can 0 go into 3? Like, we don't know. That's undefined. It's undefined. I'm pretty sure if you tried this in your calculator, here it is. It shows me 3 divided by 0 automatically tells me it's undefined. Like, how awesome is that? The calculator tells you it's not right. So, if you come across a slope that has it over 0, it's undefined. I can't divide that. Great. Last one. Yay. Alright. So, let's look at this again. This is one of our continuous graphs. I know you guys are tired of looking at graphs, but this is a really good view, okay? Time will always increase. You can never go back in time. I mean, like, I wish I could, but you can't. So we'll always go forward in time. And so we always focus on our y-axis, okay? Let's focus on this water level. So when the graph goes up, what's happening to my water level? It increases, okay? When it is a horizontal line like this, what's happening? Horizontal tells me it's constant. Okay, when my graph goes down, every time I say down, let's talk about water level decreases. My water level, every time you say down, water level decreases. For some reason, it reached this bottom, so it reached 0. Let's keep that in mind. It reached 0. This water level reached 0, and then it increased again. So it went back up, so my water level increased again. So when you read these options, which one would fit that graph? So let's read through. So pool is filled with water using one faucet. Okay, so I'm filling the pool. Then immediately after the pool is filled to its capacity, the pool needs to be empty because of some problem. Okay, well, it's filled, so that means it's increasing, right? And then immediately after, it's going to be emptied right here. After I'm filled, is it immediately after? Does it show that it's being emptied immediately after? Does it look like it? I have some kind of constant here. So we have to figure out what that constant means. Okay, so that eliminates A. A pool is filled with water. Okay, sure, it's filled with water. Filled means it's increasing. A little time after the pool is filled its capacity, the pool needs to be emptied because of some problem. Okay, so it gives it some time, a little bit of time. So that's some waiting time, right? We don't know how long. That could be the constant that we're waiting for. And then it gets emptied. And then the pool is refilled immediately after at the same rate as before. Okay, so we have to keep that in mind. Same rate as before. So you look at this rate, which is the slope, right? Because we're calling slope the rate of change. Does this rate look the same as this rate? I don't know, to me this kind of looks more steep or steeper than that one. Okay, so it doesn't look like it's the same slope, but we're going to keep this one in mind just in case, because it is still doing what we've asked, right? It increased and then went constant, decreased a little bit, and then it was refilled. So we're going to keep that in mind. So it's okay to have options. Okay, so a pool is filled with water using one faucet. That means it was kind of slow, but it still increased, right? A little time after the pool is filled to the capacity, the pool needs to be emptied. Okay, so there was given time, and then it's emptied. Okay, so that means it decreased here, and it was given time. Then the pool is refilled immediately, this time using two faucets. That means the rate was faster, right? And so in this case, it's kind of difficult, I guess, to see, but this slope right here is a bit more steeper. And remember we said the steeper the slope, the closer to a vertical line it is, right? So the bigger the slope, the steeper the slope, the greater. The steeper the slope. What did we say last time? It was from, sorry, let me go back a little. The steeper the line, the greater the slope. I'm sorry, the steeper the line, the greater the slope. So this is still going back. So if I go with two faucets, isn't that greater because it's faster? And so in this case, I would say that C would be the better option than B. Okay? And just for kicks, we'll read D, because you know you want to read through all your options just in case. A pool is filled with water, and people are having fun swimming and jumping in and out of the pool. That sounds cool, but does it tell me anything about my graph? Like, it doesn't tell me if it's being filled or why it's decreasing and what this constant means. So definitely, that's ridiculous. So, we're done with this review. So I want y'all to look over this and study for this awesome test that's going to come up next week.
Thank you, Ms. Lynn. You did an awesome job. Good luck studying for your test, guys. Bye-bye.